Chapter 5 is on linear equations. Linear equations mean we're looking at a straight line. Straight lines have a consistent change by addition, so it's going to go up and over every single time, the same amount every single time, and that consistency is what makes it linear. Linear equations will always have a degree of 1, meaning you won't have anything like x squared or x cubed. It's always just going to be an x to the first power or a y to the first power, or both. There are often questions that ask you to identify which either equations or scenarios would be linear, and the way you would do that is by checking to see if it changes by addition or subtraction, or if on the graph if it's a straight line. And that really has to do with the slope. The slope is average rate of change. That is a really key phrase. You really need to know that definition because they will use that a lot in their questions and just as they're asking things. The average rate of change, slope. Slope is the steepness of a line. We use the variable m to represent it. And so m equals, it's always going to be the change in y over the change in x. So you're always going to do your up-down change first and then your horizontal change. Another way of writing it is triangle, which means delta y over delta x. That delta symbol means change in, so really it's the same thing. A common one is rise over run. Regardless of what definition you use or how you think of it, you're always going to do your change in y, your vertical change, over your change in x, your horizontal. So there are 3 ways to find slope when you're given 2 points. You could make a table. I'm just going to move this up here. To do the table, you would put your points in. Make sure you go across with your x, y, and then you're going to find the change. So what's the change from 3 to 1? That's your change in y is down 2. Your change in x, you go the same direction. How do you get from -1 to 0? You would have to go up 1. So your change, your full slope there, would be m equals, you're going to do your change in y over your change in x. So our change in y is -2, and our change in x is +1. So that would be your slope between those 2 points. Another method to finding it is the formula, which I'll highlight that in red up here. So you can use this red formula. So again, we would do m equals, and then you're just going to subtract your y values. So you're going to do 3 minus 1 over your x2 minus x1. As long as it doesn't actually matter which one is y2 or y1, as long as you do the same for both. So if our y2, let me show this. So if y2 is 3, then our x2 has to be -1. So as long as you go in the same order, it doesn't actually matter. So you have -1 minus 0. We would get 2 over -1, and that would be your slope. The third way to find slope is by graphing it. So you would graph those 2 points. So the point -1, 3, hopefully I'll get that, and then the point 0, 1. And then what you would do, I'm going to use red to show this, is you're going to count your change in y. So you're going to do the up-down movement first. So here we're going to go down, and then we're going to go over. We went down 2, so that's a movement of -2. And then when we went right 1, so that's +1. So your slope from the graph is down 2, right 1. And so that's your slope. So you'll see that the slope here for all of these is the same. It's 3 different ways. Whatever method you like the best is fine. Okay, so there are 3 forms of equations of a line. There's standard form, which is ax plus by equals c. There's slope-intercept form, which is y equals mx plus b. And there's point-slope form, which is y minus y1 equals m times x minus x1. The reason that you have different forms is just to make your life easier. So if you're given a point and a slope, and they ask for an equation, you would want to use point-slope form. Or if you can get a point and a slope, you would use that one. If you're given a slope and an intercept, or you can get either of those, then you would use slope-intercept form. It's whatever makes your life easier. So for example, in this example, you have write an equation in slope-intercept form that goes through the points 2, -3, and 3, -4. I'm going to scroll up here. So we are given 2 points here. We need to end in slope-intercept form, but when we're given 2 points, we don't have an intercept because it doesn't go through 0, and so we want to use point-slope form. So we're going to start with the formula y minus y1 equals m times x minus x1. Now, in order to use that formula, we need, like the name says, we're going to need a point and a slope. So we're going to need to fill those guys in. So we have a point because we could just pick one of those two, and we need to get our slope. So that's your m. So I'm going to do it in table form. I'm going to do our xy. I'm going to set up my points here, 2, -3, 3, -4. And then you need to find the change. How do we get from -3 to -4? We go down 1. How do we get from 2 to 3? We go up 1. So your slope would be your change in y, -1, over your change in x, +1. So your slope is -1. Okay, so now we have our slope, which would go in there, and then we're going to pick a point and use it to fill in on our equation. So I'm going to change back to black here. Actually, why don't we use 2, -3? Okay, so I'm going to do y minus, and then -3 equals, I'm going to use yellow for our m, times x minus, and then our x coordinate is 2. Okay, so now we're in, I'm going to put a box around this because there's kind of a lot of writing on here. That is point-slope form, but the question actually asked for slope-intercept form. So how do we do that? We can multiply this out and change it around so it's in y equals mx plus b form. So first things first is you're going to use distributive property. So you'd get y. Now when we have a minus negative from here, then we can change that to a positive. So y plus 3 equals -1x plus 2, because we do the -1 times -2. Now we're trying to get in slope-intercept form, which is y equals mx plus b. So we need to move this 3 out of here. So in order to move it, we're going to do the inverse operation, subtract it over. So you're going to get y equals -1x minus 1. And that would be your equation of the line that goes through the points 2, -3, and 3, -4. It's in slope-intercept form, so we are all done. Now let's say we want to graph that line. So we're going to move down to the graphing portion here. It says to graph the line, move the equation to slope-intercept form, identify your m and b values, your slope and your y-intercept, and then you're going to plot the y-intercept and then do the slope from there. Slope is a movement, remember. So we're going to use this example from up previous, y equals -1x minus 1. So it's already in slope-intercept form, so that makes our life a little easier. We're going to identify your m and your b. So our m is up here. Your m is just the number, the coefficient in front of the x. So our m is -1. Now, when you're graphing, it's really helpful to have that as fraction, so we can always put it over 1. And then our b is this -1 on the end. So b equals -1. So b is your y-intercept, so you're going to graph that. So you're going to go down onto the, I'm going to zoom in a little bit so it's bigger. You're going to go down to -1 on the y-axis, and then you're going to go, this movement is down 1, right 1. So you go down 1, right 1, down 1, right 1, down 1, right 1, and so on. Now, you could also, you're going to follow that trend, but you could go up 1, left 1 to keep getting more points. The more points you do, the more accurate your line will end up being. So then you would draw your line through there. Obviously, it's hard to do on a screen, so make yours with a ruler, make it perfectly straight, and then you'd want to label it. Y equals -1x minus 1. Okay, the last section is on finding intercepts. Now remember, x and y intercepts. The x-intercept is where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. So to find the x-intercept, if it's on the x-axis, that means the y value has to be 0. So what you do is you plug in 0 for y, and then solve for x. To find the y-intercept, the x has to be 0, so you'd plug in 0 for x and solve for y. So in the example, find the x and y intercepts of the line 4x plus 5y equals 20. You're going to start, let's see, you're going to start with the x-intercept. And so you want to let y equal 0. So you're going to use your equation 4x plus 5, and plug in 0 there for the y. And then you would solve 4x plus 5 times 0 is 0, so you're just left with 4x equals 20. And then you're going to divide by 4. I'm going to zoom out here. And we're left with x equals 5. So your x-intercept then is going to have an x-coordinate of 5 and the y-coordinate of 0. So now, to solve for the y-intercept, you need to plug 0 in for x, so let x equal 0. And then let's scroll this up a little bit. So you do 4 times 0 plus 5y equals 20. Solve for y. 4 times 0 is 0, so you have 5y equals 20. And divide by 5 on both sides. And you end up getting y equals 4. So your y-intercept, you got to make sure that you put the 4 in the y spot, and then it would be the point 0, 4. This chapter is really important. There's a lot of questions that revolve around this kind of stuff. Some of the most common ones, I'll kind of do this in green here, is like I talked about before, determining what functions are linear. That's really important. You really need to know the slope and the average rate of change and how to find that. And then you also want to be able to find an equation of a line between points or a slope or whatever you're given an intercept. And then graphing is really important too, so make sure you know that. Also, the future chapters, like systems, is dependent upon being able to graph and knowing this stuff. So this is a really important chapter. Make sure you spend time on it.